Okay, so today we're going to be doing our Unit 4 test corrections. So our first problem says the table shows the height and the length of several rectangles. What does the correlation coefficient for the data indicate about the strength of the linear association between the height and the length of these rectangles? So we know that we're talking about correlation coefficient, so we need to do linear regression. So to do that, we're going to go to List in Spreadsheets. I'm going to put X in the A box, Y in the B box. Type in all your X values, which is your top row, 41, 70, 21, 34, 10, 92, 54, 24, 10, 35, 42, 66. Now you have to go all the way back up to row 1 and start typing in your Y values. 21, 25, 32, 12, 16, 45, 40, 23, 45, 35, 21, and 14. So let's make sure I typed in all that right. 14, 21, 35, 45, 23, 40, 45, 16, 12. Yep, I got it all in there. So we're just gonna go, we're gonna go ahead and go menu, statistics, stat calculations, cancel, I hit the wrong button. Menu, statistics, stat calculations, linear regression, mx plus b. Your X list was named X, Y list named Y. Enter, enter. So we're looking at our R value, not our R squared, our R. Our R is 0.15, so it's positive. We know that by it being a positive number. So we know it's not negative. Then this is closer to 0 because it's under 0.5, so it's a weak positive. If it was closer to 1, it would be a strong positive. Now, I want to make sure, yeah, that should be good. So that one, if you look at the graph, would be really difficult to see. So that one is a weak positive. So I'm going to go ahead and clear that one out. That one is C. So now we're on question 2. Which situation does not show causation? Keyword here is not. So that means the first event does not directly cause the second event. When the student population at a school increases, the number of teachers at a school increases. So if we have more students, typically we do get more teachers to make sure that we don't have giant classroom sizes. It doesn't work in all cases, but that does impact the second one. So that's not it, because we're looking for not showing causation as opposed to which one does. When the amount of sugar in a quart of apple juice is reduced, there are fewer calories in each serving. Sugar has calories, so if I make less sugar, less calories, that does impact it. When there are more workers on a project, the project is completed in less time. More workers causes that to get done faster. When there is more protein in an athlete's diet, the athlete scores more points in a game. So the athlete can become stronger with more protein, but that does not impact the amount of scores he makes. So that is false. So that one's going to be J. Okay. Our next one says a company advertises on a website. A worker tracked the number of visits to the website and the number of clicks on the advertisement. The table shows the data for several days. A linear function can be used to model the data. So we're going to do linear regression to find our equation. And then it says, based on the data, what is the best prediction? Prediction tells you that we're going to do linear regression and that we're going to plug in a value for X. So let's go ahead and pull up the calculator. We're going to start a brand new calculator screen to make sure we have no errors. So you exit out, don't save, open up List in Spreadsheets. Always start by doing X and Y for your labels. Now we're just going to type in all of our values. 153, 629, 471, 914, 307, 1045, 510, 1106. Okay, now we're going to go up to our other ones. 14, 38, 30, 53, 21, 60, 32, 63. Okay, so menu 4, 1, 3. X list is labeled X, Y list is labeled Y, enter, enter. And it entered sooner than I thought. Cancel. So here is my equation. Y equals MX plus B. So I'm going to write it out. We have Y equals 0.05 X plus 5.5. I'm going to round that to 4. So we're going to plug this into a calculator screen, but we're going to plug in 15,000 or 1,500 for X. So we go home, calculator, 0.05 times 1,500 plus 5.54. I get 80.54. And I want to pick the closest number. The issue with that is these are about the same distance apart. So I don't like that. So we're going to go back and we're going to use the full number of our linear regression. So let's go here, here, and I'm going to type in the full thing just to make sure that I find the one that's really closest to it. So that's 0.051935 X plus 5.5397. So if you ever round and you get numbers that are both like equally apart, just type it in again. Using more decimals. Now I got 83.4418. So just on that little thing, I know exactly which one it is. I had to include all this to get the correct number, but it did get me there. So 83 is the correct number. Okay, number 4. What is the slope of the line represented by 5x minus 12y equals 24? Well, we know that our slope is negative a over b. This is your a, b, c. So negative 5 over, this is negative 12. That's where I saw a lot of people make the mistake. Negative over a negative is a positive. So this is going to become 5 over 12. So J. So make sure that you are paying attention to if it's being subtracted, that we're treating that as a negative. Okay. Which one shows this as a relationship between X and Y? We want to know the rate of change. This is just a fancy way to say slope. Now, these are fractions, and I know if I do linear regression, it's not going to give me a fraction. So I'm going to go ahead and just do some old-fashioned addition and subtraction. So from 96 to 60, I'm going down 36. Okay, from negative 20 to negative 12, actually going up 8. So this is my change in X. This is my change in Y. And my slope, M, is change in Y over change in X. So we have negative 36 over 8. I can divide both of these by at least 4. And then I'm going to get 2, negative 9. So it's A. So you could have easily put that into your calculator as well and did linear regression. If you did, you would get a negative number that is bigger than 1. So when you get to these answer choices, only 2 are negative. This one is 9 or 9 over 2, which is bigger than 1. 2 over 9 would be less than 1. So that's one way to quickly figure that out. Okay, this next one was the one that gave people the most difficulty is what they have to do is you have to plot your point 1, -9, just right here. Now you need to use the slope of 3 to find the 0, which is when it touches the x-axis. Now the problem is -3 slope is going to be right here. That's not going to get me closer to the x-axis. So instead of going down and to the right, we're going to go up and to the left. We're going to go reverse it. So up 3 to the left 1, up 3 to the left 1, up 3 to the left 1, and we get it at -2. So -2, which I believe is D. Okay. So now we're going to go ahead and move on to the next one. Okay, so now we're going to go ahead and move on to the next problem, number 8. It says the table shows a linear relationship between the average height in feet of the trees on a tree farm and the number of years since the trees were planted. You can do linear regression on this one as well. So I'm going to pull up my calculator, move it to this side. I'm going to clear everything out because I already have some linear regression screens open. Same thing, X, Y. Type in your values, 1, 3, 6, 11, 15. Now with rate of change, when it's a linear function, you actually don't have to type in all the values. You just have to type in 2. But just to be safe, to make sure that I get in the habit of when I have linear regression or of a scatter plot, I'm going to just type in everything because it doesn't take that much time. For statistics, stat calculation, linear regression, mx plus b, x, y, enter, enter. My slope is my m, my slope is 7. So I go over here and I circle 7. If you're not sure, m is always slope and it's right there. Okay. This one says, what is the equation of the slope of the line shown on the grid? So we're going to use this with Hoy-Vux. So we know that this is a vertical, get rid of that. This is a vertical line. So this means it's Vux. That means it's vertical, undefined, and x equals, x is 6. That's my x value. So we're looking for undefined slope where x equals 6. Well, that is y, 0, x equals 6, undefined is j. So if you just remember these small little things, Hoy, horizontal, 0 slope, y equals, Vux, vertical, undefined, x equals, it gets really easy at answering these problems. Our next one, what is the equation of the line and slope intercept form of the line that crosses the x-axis at 36 and is perpendicular to the line represented by y equals -4/9 x plus 5? This right here means it goes to the ordered pair 36, 0. Perpendicular means we have to change our sign. So for my m, it goes from negative to positive. And I flip it, it goes to 9/4. So positive 9/4. This one says 4/9, so those are incorrect. We're down to 2 possibilities. So we're gonna graph them and figure out which one goes to 36, 0. So we go to a graph screen. We type in our first function, which is control divide, 9/4, parentheses, actually not parentheses, I lied, x plus 81, press enter. You can't see it, don't worry about that. That's a really large y-intercept. Just push Control T. And now we're looking for when x is 36 and y is 0. Almost there. When x is 36, I get 162. So that one is incorrect. Now, I always like to go ahead and try my other answer before I select that, just to make sure to make a typo. So when I go back, I hover over my graph until I get here, click, tab, up. Only difference is that instead of plus, it's minus. So I'm gonna go ahead and delete my plus sign and put a minus. And 36 is 0. So that one's correct. So that's how you do those. You just graph it, match the table for the order pair that it wants. Now, number 12 is linear regression again. You would just simply fill it out. You do a little table. This is my X values. This is my Y values. And we do linear regression. So I'm going to exit out of everything. Open up a new list in spreadsheets. X, Y. My X values are -4, 12, 12. My Y values are 2, 6. Menu 4, 1, 3. X list X, Y list Y. Enter, enter. Okay, so it says my M is 0.25, so we're down to FRG. And my B is 3. So the one that is 3 is F. So you can use linear regression for that. Okay. So I believe we've gone through all the questions. So go ahead and submit those answers. Oh, I lied. I went from 9 to 12. I am so sorry. I thought there was some that I missed. So we got 2 more problems left. What is the equation in slope-intercept form of the line that passes through the point 5, 0 and is parallel to the point represented? Parallel means the same slope. So this says negative, so that was positive. So we're down to 2. We're down to y equals 1.2x minus 6 and 1.2x plus 5. And we want to go through the point 5, 0. So we're going to graph this one again. Graph screen. We have 1.2x minus 6. Enter. And then we're going to hit Control T. We're looking for 5, 0. Oh, we got it on the first try. So F. Okay, we'll go ahead and give you a second to type that in. Let's go to our last problem. This one is really our last problem because I messed up before. And this is direct variation. The total distance in centimeters a toy robot moves varies directly with the time in seconds. So distance is our Y, seconds is our X. So Y over X. And it says the toy robot moved a total of 264 centimeters in 11 seconds. Distance over seconds. What is in time in seconds that it can move if it goes 408 over X? So you do bat and ball, multiply, divide. So we have 11 times 408 over 264. So I go and I get my calculator. This time, calculator screen, Control divide. 11 times 408 and then 264. And I get 17. So now we've gone over all the problems. Please make sure that you do not mark them in the incorrect order. For this one, just make sure that you put 12, which was up here, and I already solved it as 12. Okay, if you need any help, let me know, and you have a great day.